Lesson 1, Limits of a function. Main limit theorems. In the definition of each theorem, let C be any constant, n as many positive integer, and f and g as a given functions which have limit at x. And there are different kinds of limit theorem. First is limit of a constant theorem, where limit of C is equal to C with h approaches k. For example, limit 10 x with x approaches to 3 is equal to 10. And limit 13 with x approaches to 1 half is equal to 13. Limit 123, x approaches to 1 is equal to 123. And limit approaches to negative 31 with x approaches to 3 is equal to negative 31. Next, limit of a function. Limit of x is equal to k with x approaches to k. So for example, limit of x is equal to 10 with x approaches to 10. And limit of x is equal to 168 with x approaches to 168. And limit of x is equal to negative 3 with x approaches to negative 3. And limit of x is equal to negative 141 with x is approaches to negative 143. Limit of a constant in a function, where limit c f of x is equal to c limit f of x, where x is approaches to k. So for examples, limit 5x with x approaches to negative 1. So substitute the value of x. So 5 times negative 1 is equal to negative 5. So number 2, limit of negative 10x with x approaches to negative 2. Then substitute the x. Negative 10 times negative 2 is positive 20. Limit of 1 half with x approaches to 2. So substitute the value of 2. So 1 half times 2 is equal to 1. And limit of 13x with x approaches to negative 3. 13 times negative 3 is equal to negative 39. Number 4, limit of sum and difference of a function. Limit of f of x plus minus g of x is equal to limit of f of x plus minus limit of g of x. For example, limit of x minus 3 with x approaches to 10 is equal also, and perform the operation. For example, limit of 10 minus 3, then 10 minus 3 is 7. Limit of x squared plus 2x minus 1, substitute the value of x. So 2 squared plus 2 times 2 minus 1. Then 2 times 2, 4, plus 2 times 2, 4 minus 1 is equal to 7. Limit of 10x plus 5 with x approaches to 3. So 10 times 3 plus 5, 10 times 3, 30 plus 5, 35. Limit of x, negative x minus 10 with x approaches to negative 1. So negative 8 times negative 1 minus 10. So negative 8 times negative 1 is positive 8 plus negative 10 is equal to negative 2. Limit of product of function. Limit of f of x times g of x is equal to limit f of x times limit of g of x with x approaches to k. For example, number 1, limit of 10x times 10. Substitute the value of x. So 10 times 2 times 10 is 200. Limit of 5x times 10 with x approaches 3. So 5 times 3 times 10. So 5 times 3, 15 times 10, 150. Then limit of 3x plus 1 times x plus 1 with x approaches negative 1. So substitute the value of x, negative 1. So 3 times negative 1 plus 1 times negative 1 plus 1. So 3 times negative 1, negative 3 plus 1 is negative 2. And negative 1 plus positive 1 is 0. And negative 2 times 0 is equal to 0. Limit of a quotient of a function. Limit f of x is equal to limit of f of x over g of x with x approaches k is equal to limit of f of x over g of x where g of x is not equal to 0. So for example number 1, limit of x over 10 with x approaches 2. So also substitute the value of x. So 2 over 10 is equal to divided by 2 is 1/5. Then limit of 10x minus over 3 with x approaches 5. So also substitute the value of x. So 10 times 5 over 3, so 50 over 3. And limit of 5x over 4 with x approaches 9. 5 times 9 over 4, so 45 over 4. And limit of 7x over 2 with x approaches to negative 1. So 7 times negative 1 over 2. So negative 1 times 7 is 7 and over 2. Negative 7 over 2. So limit of a power of a function. So limit f of x raised to n with x approaches k is equal to limit of f of x raised to n with x approaches k. So for example, limit of x squared with x approaches k is, so our x is 10, so we substitute. So 10 times 10 is equal to 100. Then limit of x raised to 5 with x approaches 1. So 1 times 1 times 1 times 1 times 1 is equal to 1. Then 3. Limit of 2x cubed is equal to, with x approaches to 3 is equal to 2 times 3 cube is equal to 3 times 3, 9 times 3, 27. So 2 times 27 is equal to 54. And limit of x raised to 5 with x approaches 2. So 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32. Then limit of root of a function where limit nth root of f of x with x approaches k is equal to nth root of limit of f of x with x approaches k. So for example, limit of square root of x. So substitute the value of x here. So square root of 10. Then limit of 3 times square root of x where x approaches 3. Then 3 is square root of 3. Limit of square root of 13x with x approaches to 2. So substitute the value of x. So 13 times 2, so square root of 26. Then square root of 10x, so our x with x approaches 10. So square root of 10 times our x is 10. So 10 times 10 is 100 and square root of 100 is 10. In substitution theorem, if a function f is a polynomial function or a rational function, then limit of f of x with x approaches k is equal to limit of f of x with x approaches k. So for example, limit of 10x cubed plus 2x squared plus 3x minus 3 with x approaches 2. So 10, then substitute the value of x. So our x is 2. So 10 times 2 cubed plus 2 times 2 squared plus 3 times 2 minus 3. Then 10, 2 times 2, 4 times 2, 8. 10 times 8 plus 2, 2 times 2, 4 plus 3 times 2, 6 minus 3. So 10 times 8 is 80. 2 times 4 is 8, then plus 6 plus 3. So 80 plus 8 is 88 plus 6, 94 minus 3 is 91. Then second example, limit of 4x squared plus 10x minus 25 with x approaches to negative 1. So 4, our x is negative 3 squared plus 10 times negative 3 minus 25. So negative 3 times negative 3 is positive 9. So 4 times 9 plus 10 times negative 3 is negative 30 minus 25. So 4 times 9 is 36. Then negative 30 minus 25. So 30 minus 6 is 6 minus 25, negative 19. Third example, limit of 5x minus 10 with x approaches to negative 4. So substitute the value of x. So 5 times negative 4 minus 10. So 5 times negative 4 is negative 20 minus 10. So negative 30. Limit of 7x squared minus 3x with x approaches 3. 7 times the value of x, 3 squared minus 3 times 3. So 3 times 3, 9. So 7 times 9. So 7 times 9, 63 minus 9 is 54. Let y is equal to f of x be a function of x. The derivative of a function denoted by f prime such that its function value at any number x in the domain of f is defined by the formula f of x is equal to limit of f of x plus delta x minus f of x over delta x with delta x approaches 0. And there are different rules for finding the derivative. First rule is the derivative of a constant. So the derivative of a constant, the derivative of y with respect to x is equal to derivative of x constant is equal to 0. So for example, y is equal to 10. So derivative of y with respect to x is equal to 0. So the derivative of a constant is always equal to 0. Rule number 2, derivative of a power. Derivative of x raised to n is equal to n times x raised to n minus 1, which is n is greater than 0. So for example, y is equal to x raised to 6. So 6 times x is equal to 6x. Then 6 minus 1 is 5. So the derivative of y with respect to x is equal to 6x plus 5. So the derivative of a constant times a function. So derivative of y with respect to x is equal to the derivative of x with c times f approaches f of x is equal to constant times derivative of x times f of x. So for example, y is equal to 3x4. Then derivative of y with respect to x is 4 times 3, 12x. 4 minus 1 is 3. So the answer is 12x raised to 3. Fourth rule, the derivative of sum and difference. Derivative of y with respect to x is equal to the derivative of u plus minus v is equal to derivative of u with respect to x minus or plus derivative of v with respect to x. Or derivative of u plus minus v is equal to the derivative of u plus minus the derivative of v. For example, y is equal to 5x to the 4th power plus 3x squared minus x. So find the derivative. Derivative of y with respect to x is equal to 4 times 5. Apply the power rule. 4 times 5x is equal to 20x minus 1. So 20x cubed plus 2 times 3x is 6x minus 1. So 2 minus 1 is 1. So we don't need to write the 1 exponent here. So negative 1. So the answer of derivative of y over dx of 5x to the 4th power plus 3x squared minus x is 20x cubed plus 6x minus 1. Then the derivative of a product, the 5th rule. So derivative of u plus v is equal to u dv plus v du. For example, y is equal to x cubed plus 2 times x squared minus 4. So assign the u it is the u and it is the v. Then derivative of v, our derivative of v is 2 times x, 2x raised to 1. We don't need to write the 1 here. Then the derivative of u, 3 times x is 3x. 3 minus 1 is 2. 3x squared. So it is constant. So it is 0. So after assigning the u dv, we must follow the formula. So the derivative of y with respect to x, u, our u is x cubed plus 2. Then derivative of v, our derivative of b is 2x. Then v, our v is x squared minus 4. And our derivative of u is 3x squared. Then simplify. So x cubed times 2x is 2x to the 4th power. And 2 times 2x is equal to 4x. Plus x squared times 3x squared is equal to 3x to the 4th power. And negative 4 times 3x squared is negative 12x squared. Then combine the like terms. So 2x to the 4th power plus 3x raised to 4 is equal to 5x raised to 4. Then negative 12x squared, then 4x. Next, rule number 6 is derivative of a quotient. So derivative of u over v is equal to v times derivative of u minus u times derivative of v over v squared. For example, x squared plus 4 over x minus 4. So our u is x squared plus 4 and our v is x minus 4. Our derivative of u is 2x and our derivative of v is 1. So the 6th rule, the derivative of a quotient, the formula is derivative of u over v is equal to v times derivative of u minus u times derivative of v over v squared. For example, y is equal to x squared plus 4 over x minus 4. It is our u and it is our v. Our derivative of u is 2x and the derivative of v is 1. Then apply the formula. So derivative of u over v is equal to v. Our v is x minus 4 times derivative of u, 2x, minus u, our u is 2x squared, x squared plus 4, and our derivative of v is 1 over x minus 4 squared. Then simplify. X times 2x is 2x squared, and negative 4 times 2x is negative 8x, minus 1 times x squared plus 4 is x squared plus 4 over x minus 4 squared. Then distribute the sign of negative. So 2x squared minus 8x, negative times positive, negative x squared, then negative times positive, negative 4 over x minus 4 squared. Then combine the like terms. 2x squared minus x squared is x squared, then 8x, then minus 4 over x minus 4 squared. So in chain rule, let f be a function differentiable at c and let g be a function differentiable at c. Then the composition of g of f is differentiable at c, and d sub x times g circle f times c is equal to g prime times f of c times f prime times c. So formula, derivative of y over dx is equal to the derivative of y with respect to u and the derivative times the derivative of u with respect to x. So, for example, find the derivative of 2x using chain rule. 2x squared plus 5x minus 10 cube. Our u is 2x squared plus 5x minus 10. So, the derivative of y with respect to x is 3. 3 times u times the derivative of u. The derivative of u is 4x plus 5. Then 3 times our u is 2x squared plus 5x minus 10 times the derivative of it, 4x plus 5. Then simplify. 3 times 2x squared, 6x squared. 3 times 5x, 15x. And 3 times negative 10 is negative 30. Times 4x plus 5. So, 6x squared times 4x is 24x cubed. 6x squared times 5 is 30x squared. 15x times 4x is 60x squared. 15x times 5 is 75x. Negative 30 times 4x is negative 20x. And negative 30 times 5 is negative 50. Then simplify. Combine the like terms. So, 24x cubed, then 30x squared plus 60x squared is 90x squared. Then 75x minus 120x is negative 45x minus 150. Then the higher order derivative. For example, find the third derivative of the function f of x is equal to x to the fourth power minus 3x cubed plus x squared plus 10. So, the first derivative of x to the fourth power is 4x cubed minus 3 times 3, 9x squared plus derivative of x squared is 2x. Then the second derivative, 3 times 4 is 12x, 3 minus 1 is 2. Then the derivative of negative 9x squared is 2 times 9, negative 18x. The derivative of 2x is 2. Then the third derivative is 2 times 12 is 24x. Then derivative of 18x is negative 18. Then the derivative of 2 is 0. Then the derivative of trigonometric function. Find the derivative of sine 5x plus cosine 5x. So, remember that the derivative of sine u is equal to cosine u times derivative of u. Then, the derivative of cosine u is equal to negative sine u times derivative of u. So, based on the given, sine 5x plus cosine 5x, our u is 5x and our u is 5x. Derivative of sine is cosine u. Cosine 5x times the derivative of u. The derivative of u is 5 plus cosine 5x is cosine is negative sine u. Negative sine 5x times the derivative of u is 5. Then simplify. Cosine 5x times 5 is 5 cosine 5x minus, so negative sine 5. The natural logarithmic and inverse tangent function. The derivatives of same inverse function can be found by implicit differentiation. Take for example the natural logarithmic function y is equal to ln x. Note that it is the inverse function of the exponential function. To find the derivative, we first rewrite this into e raised to y is equal to x. Then differentiate implicitly. Derivative of e raised to y is equal to the derivative of x, where e raised to y times derivative of x is equal to 1 and the derivative of x is equal to y over e raised to y. Then the derivative of the natural logarithmic and inverse tangent function, for example, y is equal to logarithmic of 8x cubed plus 4x squared minus 3x. So our u is this, and remember that the derivative of ln u is equal to 1 over u times the derivative of u. So 1 over u, our u is 8x cubed plus 4x squared minus 3x times the derivative of u, 8 times 3, 24x squared. Derivative of 4x squared is 8x, then the derivative of x, 3x is 3. Then multiply 1 times 24x squared plus 8x minus 3 is 24x squared plus 24x minus 3 over 8x cubed plus 4x2 minus 3. So there is a common in their denominator, the x. So x divided by x, 8x cubed is 8x squared, then x divided by 4x squared is 4x, then 3x divided by x is negative 3. So implicit differentiation. To differentiate explicitly given function in the form of a is equal to f of x or x is equal to g of y, the derivative of function given implicitly in the form of f of x and y is equal to 0. So, for example, find the derivative for the equation x squared plus y squared is equal to 10. First, get the derivative of x squared. So, the derivative of x squared is 2y squared plus the derivative of y squared is 2y. Then times dy over dx, and always remember that every variable of y we must times dy over dx is equal to 0. So, to get the derivative of x, we must divide it by 2y to cancel. Then divide also 2y to the right side of the equation. So 2y times dy over dx over 2y. So cancel. So dy over dx then is equal to cancel 2. So negative x over y. The derivative of logarithmic and exponential function. For example, y is equal to ln times 2x minus 1 cube. We can also write it in 3 ln times 2x minus 1. Our u is 2x minus 1. And remembering the derivative of ln is equal to 1 over the derivative of u times the derivative of u. Then derivative, the first derivative is equal to 3 times 1 over u, 2x minus 1 times the derivative of u, x. Then simplify. 3 times 1 is 3 times 2 is 6 over 2x minus 1. So the derivative is 6 over 2x minus 1.